Welcome back, everyone. So today, in this video, you're going to learn about reflection. Simply put, reflection is just whenever a wave bounces off an object. For sound, we call that an echo, right? So for light, though, is how we're more familiar with reflection. You looked in a mirror at some point in your life, or the way we see is because light is bouncing off of an object and into our eyes. Right, so the light from my lamps here, they bounce off of me, that enters the camera, and that's what you're going to end up seeing here. Anything else, if you look around wherever you're watching this video, right, the things that you see are because light is reflecting off of those things and entering your eyes. When there's no light source, when it's dark, there's no light to bounce off anything, so you can't really see anything. Okay, now there are two main types of reflection. Okay, there's regular reflection. Okay, and regular reflection occurs in mirrors or other shiny, smooth objects, something like that. Basically, what that means is as the light rays come in and strike the surface, they all bounce off and reflect in the same direction. Okay, you're able to get an image off of that reflecting object, right? That's how mirrors work. That's how, shiny, smooth type things. If you have a nice polish on your car, you can kind of see your face or whatever. That is because of regular reflection. Now, another type of reflection is called diffuse, and that is far more common. Okay, most objects are not smooth or polished. They're bumpy. They have crevices, just how the atoms kind of create that object. Your skin, right? Your skin is not smooth, right? It might feel smooth, but if you microscope it down, you'll see that there are bumps and grooves and stuff just from the flakes of skin and all that cool stuff, right? So you might have a bumpy object like that. Now, when diffuse reflection occurs, basically what happens is light comes in and it bounces off in all different directions. Right, so this one came in, bounced up that way. This one came in, bounced off that way. It all scatters all over the place. You're still able to absorb the light into your eyes and see things, but it doesn't make an image, right? That's why your face isn't a mirror and we just see our own faces in other people, right? It's because our skin uses diffuse reflection, right? It reflects light diffusely. Now, regardless of the kind of reflection it is, whether it be diffuse or regular, all reflection follows something called the law of reflection. Kind of ran out of space there, that's okay. Now, I'm just going to draw here how you'll see it on your reference tables. It says theta I equals theta R. Well, by itself, it doesn't really mean anything, so let's elaborate. Okay, what that means is, let's take regular reflection as an example. It's just easier to draw and a bit easier to see. Is here you have a surface. That could be a mirror, whatever it is. Now, light is going to come in at some angle. Sometimes that angle is 90 degrees, but for our purposes right now, we're just going to say it's some other angle. Light is going to come in and strike that surface. Now, if I were to draw a line that is 90 degrees, it's perpendicular to the surface, perpendicular to the mirror. That's what this kind of dashed dotted line is. That line has a special name. It's called the normal. Right? If you remember normal force is always perpendicular to the surface. Well, a normal line is always perpendicular to the surface. It's just a term in physics. It just means perpendicular. Okay? So this arrow, this represents an incoming light ray. It's striking the surface, and we can kind of make a spot, a normal, 90 degrees to where that light ray is reflected. Okay, we see here, we can measure an angle. Okay, this is our theta I. The I stands for incident or incoming. Now, according to the law of reflection, the way the light will reflect is such that it looks like this, where this reflected ray, theta R, is exactly equal. It's exactly equal. So this angle here is equal to this angle here. That is the law of reflection. The incident or incoming angle that this ray makes to the normal is exactly equal to the angle the outgoing or reflected ray makes to that same normal. Right? No matter where on this line I start my ray, if I do it over here, boom, boom, it's still going to follow that law of reflection. Okay? Now, something that is very important to recognize is that no matter what kind of reflection it is, no matter what we're dealing with, when talking about the law of reflection, we must measure it to the normal. Okay, let me show you an example of what I mean. Okay, sometimes you might see a question ask you something like this. Right, so here's our surface, here's our reflected and incident rays. Let me draw my arrowheads, of course. Okay, and they give you this angle, the angle that the incident ray makes with the surface. You see that's 30 degrees. Now, we know from math that this case will be this 30 degrees, but that is not following the law of reflection. The law of reflection states you must measure it to the normal. Okay, so our incident angle is actually measured as 60 degrees, meaning our reflected angle is 60 degrees. That is very, 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 very important. Okay, so if they give you something like this, you have to measure what's inside. You have to measure that complement. So take 90 degrees and subtract whatever they give to you out here. Now, I just want to tell you a quick reason as to why. And it has to do with your diffuse reflection. Okay, so let me draw a couple little pictures. So you might have something that looks like this. Okay, or maybe something that looks kind of like this. Okay, now, with diffuse reflection, since it's so bumpy and so whatever, right, this angle here might not equal this angle here, but no matter what, these two angles in between will be equal. You know what I mean? So again, this might not equal that on the side, but because of the way we measure our normal, 90 degrees to some line here, these two angles will be equal. So just to recap, the law of reflection states that the incident angle equals the reflected angle as measured by the normal. And that normal is a line perpendicular to that contact point. Right? So you make a tangent, draw it 90 degrees, measure your angles based off of that, and the law of reflection states that those two angles will be equal. Okay? So, in terms of reflection, that's all I got. The biggest piece really is just your law of reflection. All right? So, with that, until next time.